Good afternoon. Welcome. Thank you for coming to our session. I'm Joe Lichtenberg. I'm responsible for product marketing and industry marketing here at InterSystems. Evgeny?
Yeah, and I'm Evgeny Shvarov. I'm startups and community manager of InterSystems.
So thank you again for coming to what's going to be the best SDC session of the whole day. At 5 o'clock, I know you could be in the bar right now, so thanks again for coming. Before we get started, I'm just curious. I mean, there's the people that we've been talking to, there's this whole range of knowledge and experience with blockchain. So if I could, by a show of hands, I'm curious how many of you, first of all, are on the development side or somewhat either full-fledged developers or comfortable with development. Oh, that's awesome. So I think everybody is a developer, including Helena. How many of you have experience with blockchain, even if it's just very lightweight experience? Okay, I would say maybe 15 or 20%. So that will actually help us in terms of how much we take for granted and how much we go into detail. So we're going to cover a lot in this session. One of the key points that I hope that you take away from this session is that blockchain is a technology that is, most commonly used as a part of an overall application, enterprise application typically, to solve very specific problems. So in contrast to like Bitcoin, which is, it's a blockchain, what we're seeing, at least from our lens into the marketplace, is that these applications that do a lot of things and they have integration and there's multiple participants in a drawn-out process that's very often distributed, and it's got many touch points, right? How do you either, number one, have a permanent, immutable record of everything that happens, and then number two, if there's an opportunity to disintermediate, in other words, if you have a trusted central authority that needs to be associated with the transactions to be able to validate them and verify them, that's a type of process that's ripe for disintermediation, and blockchain can help with that as well. Okay, so here's roughly what we'd like to go through in the next 40 minutes or so. I'll give you a deep dive, we'll get sort of techie on the blockchain technology itself, and then come up a couple of levels and talk about why organizations would want to use blockchain and what some of those reference architectures look like and how they're being used in various industries, with the thinking that if you have sort of a business application view of how blockchain is being used to make processes more efficient or to solve certain kinds of problems, it might help you think about where in your organizations it might be a good place to try to implement blockchain as part of business processes. And then for those of you who saw the presentation this morning, was everybody in the morning session at about 11 o'clock? Most of you, great. So that application that was built by one of our partners, Evgeny is going to go into in a lot of detail, and we'll be able to take questions. I'm sure it will sort of trigger thoughts and questions. So we're going to get into that in detail. Evgeny will also get into detail what the adapter that we have for Ethereum is able to do and how it works in the demo application that you have. All of that's available on our open exchange that you can download and use and work with and experiment with the demo application that's there. Okay, so give you a simplified description of how the blockchain technology works itself. So you have a transaction, right? And the transaction gets created, and before the transaction can get approved, it must be validated by the nodes in the network. So there is a process that different blockchain networks handle differently, but there is a very complex set of transactions that has to happen in the world of Bitcoin. They call it Bitcoin mining, and there's flexibility in terms of the calculations that the blockchain network will put the transaction through. But essentially, there's a level of work that's required that makes it difficult to create transactions that are fraudulent or try to spoof the network. So if it's validated by the nodes in the network, the transaction is added to what's called the block. And then as part of this block, there's another set of calculations that essentially results in a unique hash value, right? And so that set of calculations incorporates every record of every transaction in the block. It incorporates the hash value of the previous block. It incorporates a nonce, which is a unique number so that you cannot reuse a transaction. A transaction can only be used once, right? So to create this block, there is a tremendous amount of calculations that are required. And again, the calculation of that hash value has to be more difficult than a certain difficulty value. And usually it's not. So the algorithm keeps calculating hashes and I think thousands or tens of thousands of calculations before it gets to a point where it's a sufficient difficulty level where that you have the hash that you can use. And again, as part of that hash is encoded the value of the hash of the previous block. So now the block gets added to a blockchain, which is a sequential list of all of the blocks that contain all of the transaction records in a certain order. The hash values validate the order, right? So all of the nodes in the network have the same copy of the blockchain. It gets distributed to the network. So why did I go through all of that? So it's really, really complicated, and I'm not the guy that is going to give you the deep dive on all of the math behind it, but the net of it is that once a transaction is approved and made part of a block, and the block is added to the blockchain and it's distributed to the network, for all intents and purposes, it's permanent, it's immutable. So computationally, it's extremely, extremely difficult to go back and make a change to it. So a blockchain is ideal for making sure that any transaction that occurs cannot be spoofed, right? Can't be replaced. So it's immutable and it's secure. It allows me to go back and audit and trace every transaction at every step in the process at any time in the future with an extremely high degree of confidence. The other thing that it does is if you look at business processes where it relies on a centralized third party, like a bank, right? Which is why blockchain is so valuable for virtual currencies, digital currencies like Bitcoin, right? It's because without that, typically you need to have a bank, the Federal Reserve, you need to have a bank standing behind currency. With Bitcoin, you don't, right? And so, I mean, obviously it's good and it's bad. It can be used, you know, It allows money to be transferred out of countries for questionable products and things like that, right? But it also solves a very important problem, which is to disintermediate money. And it can disintermediate any kind of process. So for stocks, I talked about it a little bit this morning. For stocks, when you buy and sell stocks, right, there's a clearinghouse, the DTCC and other clearinghouses. And it used to be T+3, 3 days to clear and settle a trade. So what that basically means is the paperwork that goes back and forth and the funds that go back and forth when I buy or sell 100 shares of IBM stock. Now that can happen immediately, right? Because I can make an immutable record of all of the transactions of the buyers and sellers of the shares of stock, right? Without necessarily having a trusted central agent that's involved in the transaction. So one of the attendees here that I was speaking with is spent his entire career in financial services and actually worked with a subsidiary of the DTCC. And I asked him about this, and he said, "This is absolutely what's going on." And I asked him, "Is the DTCC going to go away?" which is the clearinghouse. And he said, "No, it's not going to go away, but it's absolutely going to change their world." Right? I mean, it's turning their business upside down, and they're still going to be involved, but it's going to be much less of ownership of the process, and it has the ability to disintermediate, right, in all different industries, and obviously to improve efficiencies and lower costs. And so I'm going to talk about a number of different industries in a few more slides and use cases where this is starting to be applied. Is it me? Do I need to put this higher? Okay. Feels like it's going in and out. Okay. So with that as an intro, Evgeny is going to take us through the work with the adapter and the demo and open exchange.
Hi, everyone. Yes, as you know, InterSystems Data Platform is an interoperability platform. So you can easily introduce an adapter, so did we, and we introduced InterSystems IRIS Interoperability Ethereum Adapter, which lets you expand your interoperability solutions with IRIS and use Ethereum network to work with transactions, read and write, and work with smart contracts. Let's go through that. Actually, how can you work with Ethereum? So as Joe mentioned, it's a network. So the easiest way you can introduce your own node to this network, for example, with Geth client, and then communicate with that. Or you can use any cloud provider, like Infura.io. And in our InterSystems IRIS Interoperability Ethereum Adapter, we introduce both ways. So, and along with the ObjectScript package, we deliver also a Node.js library, which communicates with a well-known Web3.js library which lets you work with Infura.io or your own local node of Ethereum network. So, and you can get it today on Open Exchange with full source code, and you will be able to read and write to Ethereum and work with smart contracts. And along with the source code, we also deliver a small Hello Ethereum demo, which illustrates all these actions. Okay, so before starting to work with the Ethereum network, you need to do some settings, configuration settings. First, choose a network. And actually, as you may know, besides the main network, there are a bunch of test networks, which are literally the same as Ethereum network, but you can work with this and don't pay money. So the most known are Ropsten and Rinkibai, and we work in our case with Ropsten. And kind of the next step is to create an account in this network. Because all the transactions in Ethereum networks, they should be signed, and you should pay some money, even virtual money. So that's why you need an account, and you can create it, for example, with a MetaMask plugin for a Chrome. And the next step, you need this money. And for a mainnet, you need to pay real money. And for the testnet, for example, for Ropsten, you can easily pop up with a faucet MetaMask IO. So you're almost ready, and you just choose the way how you would communicate with Ethereum network via InterSystems IRIS interoperability Ethereum adapter, or either with a local node or with a Infur IO, and start to do this. Okay, let's start, for example, from the simplest operation, reading from Ethereum. And actually, maybe the most simplest operation is about money. So we implemented in our adapter a method getBalance, yes, which helps you to get the understanding of amount of money on any account in network. So it's public, open network, so you can get this knowledge for any account there. So to do that, you just provide the address of a wallet and call it. And let's examine my account. So it has 19 Ethereum. Let's call balance request. So seek my secret number of wallet. And we see that it is 19. Do you see that? Yes. So, OK. And actually, let's go to the next step. And this is the most coolest thing about Ethereum network, smart contracts. What is it basically? So actually, smart contract is a code which is deployed in a transaction, and it can be executed with methods. And also, it's a database, so you can store the data within a smart contract. Yeah. And with the Ethereum network, you can write these smart contracts via special language which is called Solidity. And in our Hello World sample, we introduced a very sophisticated smart contract, hello contract, with two methods: setName, which is transaction which sets a property name in the smart contract, and the second method, hello, which extracts, which returns, which gets this stored property and to a caller. To deploy this contract into Ethereum network, you would need to compile it, and there are a bunch of methods how to compile a smart contract, and you can do this, for example, with a cloud compiler, remix.ethereum.org. And as a result of compilation, you would get two things. The first is ABI, which is basically the specification of smart contract. It can be in different forms, but we chose a JSON form, which is it's readable, so it's a cool thing. And the second parameter is bytecode, which is not very readable, but it helps this smart contract to run, to execute. OK, let's deploy it. Here is the InterSystems object script. And as I said, this deployment is a transaction. So to perform this transaction, you would need your account. You need to sign this transaction with your account, and also you would need to pay some money for this transaction. And here we see 1 gigaway, 1 billion of ways. Ways are kind of cents of Ether. So it's really small part of Ether, of real money. And you provide ABI and bytecode. So let's see how it works. What's cool about Ethereum, so you can, it's a single source of truth. You can check all the transactions on Ethereum, all the hashes at any time. It's immutable. So as Joe said, it's something you can check at any time. So let's call it. So I provide the parameters where I store ABI and bytecode for this smart contract. OK, we got a hash. Yeah, let's get this hash to check in the Ethereum. So we are reading this data. So here's the hash. And yeah, we're checking this in EtherScan. EtherScan is one of the popular scanners of all the transactions in Ethereum network. Yeah, and we have it here compiled. Great. Let's go further. So okay, we have a contract, so we can work with it. We can call methods. So let's call it setName. And again, it's a transaction, and the changes that comparing to previous deploy method is that you need to know the address of the contract, and you again sign this transaction with your account and pay some money, and then we have this variable in object script and just call setName method as it is a usual object script method. So let's do this. Let's put the Global Summit 2018 into setName parameter. Yes, it is a hash, and let's see. We see the transactions, all transactions of this particular smart contract. We call it setName method, and the data is Global Summit 2018. And what is cool, you can check it now, so it's there. Okay. And how to get some data? So let's call method hello. The difference here that for reading from Ethereum, you shouldn't pay anything, and it's not a transaction at all. So you can read all the Ethereum at any time. And so it showed the result, yes? So let's check that. Let's call this hello request. Yes, and it needs a year, and it returned hello, Global Summit 2018. Cool. So now, Joe.
Yes.
Was it exciting?
It was for me. Yeah. So, you know, I think yes, and I think the takeaway is I can see how, you know, we can start to think about blockchain as just a component of an InterSystems IRIS application. So, you know, you build the applications that you're building anyway, or you may already have running, and where it makes sense to integrate with a blockchain network like Ethereum or other, right, you can incorporate that into setting values, writing values, and retrieving them at various parts of the process, right, of a composite business process. So I don't know if this is readable or not. The slides are available online. But the interesting thing, the reason that I included this slide is it gives you a good sense of where in a whole range of industries and in government, blockchain is starting to be used. And you know, anecdotally, what I'm hearing is that there's still issues around performance, around scale, but they're, you know, rapidly being addressed. And so there's companies that are now experimenting and building MVPs and experiments in different areas so that in parallel, as the blockchain technology further matures, right, they're ready to go. And there are a number of use cases, a relatively large number of use cases in production right now with the early adopters. So we're going to talk in detail about pharmaceutical fraud. I talked about in the financial services world around clearing and settlement of trades. In shipping, container ships, you might not be aware, but at any point in time, you know, a container shipping line has like 10 million containers that are in transit around the world. So if you take, you know, any of the container shipping lines right now, and if you ordered something on Amazon 3 days ago, right, there's a pretty good chance that it's on a container ship. or something that you order in the future is on a container ship now, which is actually more accurate. That's how everything gets transported around the world from manufacturer through the distribution chain. And from start to the end of the journey of a container ship, it touches all of these different parties in terms of loading and unloading. There's documents, and there's weigh bills and bills of lading, and all these different documents associated with it. And it's just ripe for fraud. And so using blockchain to be able to document every party that touches the shipment at every step along the way, and to be able to manage all the documents, the certificates of origin, and so on that are associated with it, it's really a very strong use case for being able to track with container ships to get a couple of benefits. One is there's theft, right? I mean, things disappear from containers, right? That's one. But in terms of removing friction from the process to save money, one of the major container shipping companies estimates that by incorporating blockchain into their current processes, they can save $5 million per journey for each ship. Right? So, you know, there's big savings and big efficiencies that can be generated. Another interesting example where blockchain now is being used, it's very innovative. So you know that for music artists, you know, there's sort of never been a worse time, right? So the ability to go, I mean, this is how my kids listen to music now, right? I mean, they go, they're not, I don't even think you can buy a CD anymore, but they go, there's a song that they like, and they go on YouTube, or they go on, you know, someplace else, and they play a video of the artist, or they stream the song. And so what's happening is, you know, in theory, the artist is supposed to get royalties every time the song is played, but it doesn't happen. So there's, you know, so many participants in the chain that are missing out, especially the artist, by sort of this, you know, disintermediation of the assets, of the music assets. So what the music industry is doing is they're building a special player that requires, that has blockchain incorporated into it. And to be able to play the song, you have to play the song with this particular media player, and it logs every play of every song, whether it's coming from Facebook or Twitter or, you know, whatever website, so that they can collect the appropriate royalties, right? So all sorts of use cases for sure. Another interesting one in automotive. So when you buy a used car, you know, has it been stolen? Is there flood damage? Has the odometer meter reading correct? Right. So every step in the sort of the ownership of the car gets logged. And so when you go to buy a new car, you can check all of that. Okay. So Evgeny is going to take you through this example for pharmaceutical fraud. For those of you that saw the presentation this morning, right, here are some of the current problems associated with theft of pharmaceuticals and being able to replace that with fraudulent or counterfeit drugs. It's a very serious problem. So this is just a sampling of the countries that have created regulations around serialization. Has to do with, you have to put a unique barcode on. They now have these invisible dies or taggants that you can scan like a barcode, but you can't see it. And so it's much, much harder for a counterfeiter to spoof, so that at every step in the process you can scan the barcode, you can make sure that the appropriate taggant or die is still there, and you can write all that to the blockchain, and then track and trace. So a track and trace application uses serialization to be able to track exactly what's happened at every step in the process. So I think you saw something similar this morning many places where the criminals can take a carton, package of drugs out of the process and replace it with something that's counterfeit. At the overall process, this is, you know, a canonical InterSystems IRIS or ensemble process, right? It's interoperability, it's a composite business process, it's touching the inventory systems, the ERP systems of the various owners, stakeholders in the chain. So the ability to incorporate blockchain as part of those business processes, as part of those productions, right, adds, you know, instant value. Okay, so with that, Evgeny, do you want to take us through the demo?
Thanks, Joe. And our partners build a system which goes through this process and fights pharmaceutical fraud. So, and in the heart of this system is InterSystems IRIS data platform, which helps to register all the participants of the supply chain process into Ethereum network to be sure that only legitimate actors can make transactions with certain medicines in a supply chain. And let's see the journey of medicine. Manufacturer produces some pharmaceutical, and then using InterSystems IRIS interoperability adapter, writes this data into Ethereum contract. Then he sells these medicines to distributor network, and this information is being written via InterSystems IRIS interoperability Ethereum adapter into smart contract. And on the next step, distributor sells these pharmaceuticals to retailers, and again, this information is being stored into Ethereum network. On the final step, patient gets the medicine, and he can check all the journey of the medicine via reading, for example, this QR code on his mobile, and see the whole supply chain journey and all the participants and how this medicine was delivered to him, and there is no fraud here. Let's see how it works. So we see the application which written on InterSystems IRIS data platform, which helps to register all the participants in the system and let them go through an approval workflow which regulator provides. Now we see manufacturer information system, which is actually some ERP system, which uses InterSystems IRIS Ethereum interoperability adapter to store the data when, for example, manufacturer produces some medicine, and yes, here are, for example, QR codes of this medicine, a batch of several medicines. And it stores this data into Ethereum network. And here, that's how the journey starts. And we can check all these transactions online on Ethereum network at any time. Sometimes it takes time because it needs it's mining to work with that. Yes, let's check. We see that this transaction was approved. And we can examine every medicine via InterSystems IRIS solution and see that, yes, it was produced by this manufacturer. Here we see how manufacturer sells these medicines to a distributors network, to legitimate distributors, and stores this information to Ethereum network again. Yes, now we see this distributor's information system. It's yet another ERP which uses InterSystems IRIS data platform to work with Ethereum, and here distributor sells medicines to retail network, and this data is being stored into Ethereum. Yes, we see that, and let's check the status of the medicine. Yes, we see now that this particular medicine is sold to a retailer. Okay, let's try to sell a fake medicine. And we're introducing the ID which which is fraud, and let's try to save it. And we see that transaction is declined because this medicine is not listed in a smart contract in Ethereum. So here we see the final step, a cash register, very simple process when we sell the medicine to a patient. And yes, even here, the cashier needs to store this data into Ethereum, and it's done. And okay, let's do a double sale. Why not? Let's try. It doesn't work because in a smart contract we have this information about this medicine that was already sold. So, and this transaction has failed. Yeah, and so the journey of our medicine is over. We have a happy customer, happy patient, who has all the information about medicine that is not fraud, and he can check it using his mobile. And actually, you can check it now, and I will do this too. So you can, it should work. So let me. Yes, it works. So you can try this with your mobiles, please. So and I bet you don't see this, but you can check with your phones that system is in action. And I can say that using InterSystems IRIS Interpretability Adapter, you can work with, you can build solutions where blockchain can play some role in your solutions and applications. Yeah? Yeah.
So if you go back one slide.
Sorry. Yeah.
Yeah. So I'll just, it's everything that we talked about. I'll let you read that. But again, you know, I think the main point that we want to stress is that blockchain, again, is one component of an overall application, a typical cache, ensemble, InterSystems IRIS application that can bring a lot of value, additional value, in terms of these benefits that we talked about. And you have the technology. So you have the adapter, you have the demo app. It's available on OpenExchange. So it's there for you to download and start to play around with and hopefully embed into some of your applications.
Yeah, and we have 5 minutes for questions. Any questions so far? Yeah, sure.
So I'm still doing this. So is the transaction block actually written in IRIS, or is it written in Ethereum and we just get a pointer to that transaction?
It's the latter. So anything that you can do in IRIS previously, that's what you do in IRIS. So you will still have the details of the transaction, but to create the immutable record, and if you choose to use blockchain, that's done in a blockchain network of your choosing, and we create the adapter to it.
And is the network here Ethereum, and you have other networks, or are we talking private, public?
It's a great question. So the first adapter, hot off the presses, that we just wrote and we put in OpenExchange is for Ethereum. But from Ethereum, from that adapter, it's straightforward for us to build an adapter to other networks. But the one that currently exists is for Ethereum.
Yeah. As Joe said, you can just expand your InterSystems IRIS solution, starting working with this Ethereum using this adapter.
I'm just thinking more along the lines of on the healthcare side, one of our biggest problems is patient identity. And if we can create a public or private chain that can help manage identity, it might help with some of the exchange. So.
Yeah, it's a great use case.
Yeah, perfect use case. You can do it today.
Sure.
Yeah. Any more questions? Yeah, and actually speaking about other networks, the private and public ledgers, you can build an adapter and work with that, or maybe wait a bit and we will build this.
But the adapter is really just communicating with the chain. It's not
Yeah.
actually a node on the chain.
No. It communicates with the public gateway or with literally with a node. But as you saw, in order to make transactions, you need to sign it, you need to pay for this for public blockchain. Yeah, this kind of stuff.
I was just thinking more along the lines of, I have 3 places that I do business with. We all have InterSystems as a solution. And I want to create a transaction record with the 3 organizations that track as we exchange information privately, not with Ethereum, not with anybody else. It's a private chain with our organizations, working through how that would work outside of Ethereum or anybody else, any other publicly.
So that's a private subscription-only blockchain, right, that you would use. And for example, you might use Hyperledger or other, and then the architectural diagram would look like this. The difference would be instead of, right, so you have a process flow and they're external separate organizations that all should have access to write to and read from the private blockchain, but it's subscription only and it's private. So it would look just like this. The only difference is rather than using Ethereum, you might use Hyperledger or some other private blockchain. That's how you would do it. Great. Any other questions? Okay. I'll see everybody in the bar.